Illustrative hypothetical scenario. This is not a reported incident. An AI refunds agent receives a valid customer identifier, a permitted action, and a correctly structured request. Every schema check turns green. Yet the identifier resolves inside the wrong tenant, so the agent updates the wrong customer. Nothing was malformed. The side effect still succeeds. The missing control was proof that this value referred to the exact intended live object. Semantic integrity asks whether a value keeps its meaning, the same unit, field, and business rule. Referential integrity asks a different question: which entity does that valid value identify? A production reference needs more than a plausible string. It must bind the owning service, resource type, parent or tenant, canonical name, lifecycle identity, and the action being authorized. That boundary deserves its own gate. Several paths can break that binding. A display name or email may not be unique. A short ID loses its parent scope. An alias is reassigned. A deleted object is recreated under the same human-readable name. Or the object changes between review and execution. In every case, the payload may remain valid while the referent is ambiguous, replaced, unauthorized, or stale. Foreign keys maintain database relationships, but one database constraint cannot prove cross-service tenant authorization or lifecycle identity. Before planning a side effect, build a reference envelope. Include owner, resource type, tenant or parent, canonical resource name, immutable lifecycle UID, current ETag, and intended action. This is a design pattern, not a universal standard. Keep human labels for display, but never let a label silently replace the canonical reference used for control. Prefer opaque identifiers over natural keys. Next, resolve deterministically through the system that owns the resource. Convert any accepted alias to its canonical name, then require exactly one match. 0 matches means stop. Multiple matches means stop. For a high-impact mutation, do not let the model choose with fuzzy similarity, memory, or a best guess. Resolution evidence should identify the authoritative source and time of lookup. Treat cached mappings as evidence with expiry. Now check scope and authorization on that exact object. Confirm the resolved tenant and parent match the approved context, and confirm the actor may perform this action on this resource. A UUID can reduce accidental collisions, but it is not permission and should not be treated as a security capability. A syntactically valid identifier can still select another customer's record. Lifecycle identity matters too. Some platforms allow a new object to reuse a deleted object's name. The new object may look familiar while carrying a different UID. Verify that the target is active, not deleted or tombstoned, and still has the expected lifecycle identity. If the name was rebound or the UID changed, require fresh resolution, policy checks, and authorization. Finally, revalidate at commit. Fetch the authoritative current state and compare a strong ETag, version token, or the service's documented equivalent. Apply the mutation conditionally with if match. If the precondition fails, do not hide the mismatch with an automatic write retry. Return to resolution and authorization. HTTP may report 412 precondition failed. Other APIs can use a service-specific conflict response. Never guess around a failed precondition. Test the boundaries, not only the happy path, same labels across tenants, a valid ID in the wrong scope, alias rebinding, delete and recreate, a stale ETag, and a change after approval. Record the canonical reference, lifecycle identity, version, resolution source, authorization result, and action ID without unnecessary personal data. The operating rule is simple: no exact, current, authorized referent, no side effect. Fail closed.